and report of our database application, the online car dealership. So these are the things that we will be going through in this report: a basic application overview, the functionalities and the constraints applied on those functionalities, the tools used, some diagrams and models to define the database, and then we look at some queries, then move on to the demonstration of the project. So before we start, I'd like to say that it's recommended for you to first go through the entire report, because this report provides everything that I'll be mentioning in much more detail. So we will be going through only the main points here. So this application gives its users access to a countrywide network of dealerships that sells 3 products: cars, spare parts, and tires. The goal is to give the customers a means to search through catalogs and get a recommendation and find the nearest dealerships without actually having to go to an actual physical dealership. So let's talk about these functionalities that I just mentioned. Firstly, the catalogs inside are the master detail tables of car, spare parts, and tire entities. So these are not just catalogs displaying the entire contents of the tables. They also deploy a search tool which takes in search queries and then returns data and records from the backend from the tables. More on this search feature when we get to the demonstration part. All right, then the application can be navigated through a side menu, which will list all the pages of the websites, which will include 5 of them: the 3 catalogs, the recommender section, and the GPS locator, which will be labeled as find the nearest dealership. So for the recommendation functionality, we take the exact search query tool as previously mentioned, but we take it to another level. It has more functionality than the previous search tool. What the user can essentially do is provide the application with a list of attributes that they would like to see in a car, and then the database can provide the recommendation through search queries based on that. We will be discussing more of this enhanced search tool when we get to the demonstration part. As for the GPS functionality, the app does not deploy an actual GPS signal on a serviceable device. What it does is that it displays cities and areas and asks the user to choose the city that they're in and the area that they're in, and then give them the ID of the nearest dealership and the name of the nearest dealership, along with the distance that they are from the dealership. If they are situated in, if the dealership is situated in the city and area that they are in, then the distance is displayed as 1 kilometer. There are a multitude of constraints applied, which include unique constraints, check constraints, primary, and foreign keys. These will be discussed in the data model and even in how they're applied in the query section. So for the technologies and tools used, you will notice that we have not mentioned the one tool, which was the Oracle REST data services in our list here, which was previously mentioned in the proposal. That is because we used a completely built local database. So we built our own complete database. We did not require REST services from Oracle, which is why we used Apex for the front end and for loading data, and the SQL developer web to execute the queries, scripts, and make the database objects. Now we will be moving to the entity relationship diagram.
Okay. So the this is the anti-relationship diagram, which we have made in the Crowfoot edition. The dealership seems to be the focus of our EID. It has 4 attributes: the dealership ID, the name, the area, and the city. The dealership, furthermore, has 4 other primary relationships, starting from the car availability, uh, which has a relationship with the dealership using the available at relation. It also has many-to-many relationship with each other. And then the car availability itself has a many-to-one relationship with the car using the car's available relation. The car has plenty of other attributes such as chassis number, leasing, and everything else we might use in order to further detail the type of car one might require. The the primary key of the car is the chassis number, and the primary key of the dealership is the dealership ID, as you can see. The primary key of the car availability is the primary key of the car and the primary key of the dealership combined. This strengthens the bond between them and makes our ERD more concise. Um, Borrowing from this, the second relationship the dealership has is with the tire availability. It has a main-to-main relationship using the available at relation. The tire availability in turn has a many-to-one relationship with the tire using the tire's available relation. The tire has the tire ID as primary key along with the brand, the tread type, the tire size, terrain, and the model. The tire availability's primary key is also borrowed from the primary key of the tire and the primary key of dealership ID. The third relationship the dealership has with the parts available, it's also a many-to-many relationship using the available add relation. And the parts available also has a many-to-one relationship with its spare part using the parts available relation. The spare part has three attributes: the made for, type, and the part ID, which is its primary attribute. The parts availability, just like its predecessors, has its primary key is done by combining the primary key of spare parts and the primary key of dealership. And the final relationship the dealership has is with GPS. As one can see through the ERD, it's a weak relationship, as the GPS cannot exist without dealership, and so it is completely dependent on it and is not its own thing. Dealership has a uh, many-to-one relationship with the GPS using the tracking isolation. The GPS also has four attributes: the nearest ID, distance, nearest name, and the city and area. Okay, and now I will be moving on towards data model. Now, as you can see from the data model, the first table, the car availability, has a primary key, which is the dealership ID and the chassis number, which are both foreign keys inherited from the car table and the dealership table. The car table in turn has a primary key, the chassis number, and all the other attributes that we saw in the previous uh, part section. Then we see the dealership table, which has dealership ID as primary key and the name as its unique attribute. It also has city and the area. Then it also acts as a parent table for these other three tables: the tire availability, the part availability, and the GPS. The tire availability also has a primary key, dealership ID, and tire ID. Dealership ID is a foreign key inherited from dealership, and tire ID is the foreign key inherited from tire table. The tire table has the primary key tire ID and the unique key model, and it also has the attributes that you saw previously. And then we move on to a part availability table, which has the primary key dealership ID as well, and the part ID, which is a foreign key inherited from spare part. The spare part has the primary key part ID and the attribute type and made for. And then finally, we move on to GPS table, which has the primary keys, the city and the area, along with the foreign key, which is the nearest ID, which is inherited from the dealership ID, you could say. And then let's also finally head towards the anti-relationship schema. The anti-relationship schema could be said to be a simplified version of the previous relations we've seen in the data model and the ERD. As one can see, we can start from dealership, then move on to GPS, the car, the car availability, the spare part, the part availability, the tire, and finally the tire availability. And now let's just move on towards the queries.
All right, now for query section. You can go through the section to find out what exactly our backend is built on. It will be redundant to go through each of the creation of the table. Here we see the car table with the mentioned attributes and the constraint primary key. Here, this is one thing to note, that this is a picture attribute block type in the car. Here's a check constraint on car. Safety rating has to be between 0 and 5. Unique constraint on the car. Unique constraint on name in the dealership table. Here's a foreign key. The nearest ID is the foreign key, which references dealership ID in the dealership table. Similarly, we've got some more primary keys, foreign keys, like a foreign key here, dealership ID, which references dealership ID again in the dealership table. This is the same for every relationship kind of entity, which are car availability, spare part availability, and tire availability. These are some samples to understand the implementation of the recommendation functionality that was previously talked about. It's a simple search query where the user can search for, let's say, enters the brand Toyota and the car model Fortuner. Recommendations can be based off of that, or maybe the horsepower being less than 300, car color being red, or maybe between airbags between 2 and 4, capacity equal to 4, car types, financing, where the expression is yes or no. Here are some samples to understand the implementation of the location functionality, where the user can enter a city and an area, or even a single city which displays all the areas in that city, or even two cities which displays all the areas in both these cities. Now that's it for this report. Let's move on to the fun part, which is the demonstration of our project. So I'd like to state first that this project is completely deployed, so it's on the web. It's not specific to my machine. It can be run on any machine. We have assigned some privileges, administrative privileges to some accounts and read-only privileges to some. This is the homepage, and here you can see the 6 pages that we can navigate to. Let's first go to the car catalog. As mentioned before, the car catalog has a complete master detail page of our entire car table with brand, model, horsepower, and all other columns. So one thing that these catalogs implement is the search query. So how this works is, actually, let's first go into the details of each of these cars. So you can see here that you can view more details in a different format, in a form format, when you click on any of those records, and even a picture of the chosen car. Let's go back to the car catalog. Let's look at some other car. Let's say the Ford F-150. Here's the details of the Ford F-150, horsepower 430, color white, type truck, the mileage, the seating capacity, and a picture here. All right, back to the car catalog. So here, now for the search functionality, let's say the user types in Nissan and searches for it. The cool thing about this search query functionality is that if I enter a variable character in here, it will search for the variable character in every column that holds a variable character. So although Nissan will be found most probably in the model column and nowhere else, it will still search in every single column that is a variable character. So here we have some, actually all of the Nissan cars in the catalog. Let's look at one of them. Let's say the Nissan Sentra. Here's the details and the picture. Let's go back to the car catalog. We can also do multiple search queries. Let's say I want red crossovers. Red crossovers, crossover. So these are 2 queries, and turns out that we have only 2 cars that are red and they are crossovers. Let's look at this one, Nissan Armada. Here's the details and the picture of this car. All right, now moving on to the spare part catalog, you can see the type and the cars that this is made for. All right, we can also search here for cars. Let's say we search for the Sentra, and we can see that headlights, backlights, bumpers, side mirrors, and spoilers are available for the Sentra. That is also exactly how the tire catalog is implemented. It has some columns like tread type, which are either symmetric, asymmetric, or directional. Terrain, brand, model. Model is kept unique for implementing extra for its functionality. You could turn this into a foreign key, although we have not, but there is always room for that extra functionality. And the tire sizes, which are, yeah. Now, moving on to one of the most important features of our project, which is the recommendation feature. This might look as the same as the car catalog, but it implements a very important feature, which is an upgraded search bar. Let's say I'm the user and I want a car with, let's say, exactly 6 airbags. And I also tell the application that I want the mileage to be, let's say, greater than 5. And let's say that I also want financing to be available on this car. So apply this. And here's our recommendations. Here are 8 recommendations. So let's look at them. This is the Ford that we looked at previously as well. Let's go back to some other car. Let's say this one, the EcoSport. Here's the EcoSport, which looks like it's going fast, but it's not. Finding the nearest dealership is another important feature. So what the user can do here is enter a city or an area and get details on the nearest dealership. So let's just go into the first one. Let's say my city is Aptabad and my area is Army Kent. I see that the nearest dealership is that of ID 1010. The name of that dealership is Auto Room, and the distance from my area of Army Kent is 7 kilometers. Going back to the nearest dealership. Now let's say the user wants to enter his city as Multan. So I'm in Multan. I can see that there are 5 areas listed. There are 5 areas listed for every city in this database, and every city has exactly 2 dealerships in any 2 of the 5 areas that it has listed. So here's Multan, and let's say I'm in Musa Park. So the nearest dealership from Musa Park is Affordable Rides with a distance of 12 kilometers. Going back here, let's search with an area this time. We could do both as well, city and area. Let's say I'm in Johar, which is in Karachi. So there's one entry, Karachi, Johar. So it turns out that the nearest dealership in Johar is Babar Motors, which is in Johar. That's why it says 1 kilometer. So it's situated inside of the area that we searched for. This was our demonstration of the database project and the report. Thank you for your time.